A galaxy can die without losing a single star. All it has to do is stop making new ones. Stars need cold gas to form, mostly hydrogen cooled down to just a few tens of degrees above absolute zero. In a healthy spiral galaxy, this gas collapses under gravity into dense clouds, ignites nuclear fusion, and lights up as bright blue, short-lived stars. But when the supply of cold gas is cut off, or heated so much it cannot collapse, starburst shuts down. Astronomers call this quenching. A quenched galaxy is not instantly empty. It's more like a city that has banned children. The existing population ages, fades, and reddens, and after a few billion years, the galaxy becomes a quiet graveyard of long-lived, reddish stars. One of the most brutal places for a galaxy's star-forming gas is a galaxy cluster. Clusters are enormous structures, containing hundreds or thousands of galaxies orbiting inside a shared halo of dark matter and a vast atmosphere of gas called the intracluster medium. This gas is thin, but blisteringly hot, tens of millions of degrees. So hot, it shines in X-rays. When a galaxy falls into this environment at a few thousand kilometers per second, it feels a kind of wind pressure, like your hand out the window of a speeding car. This ram pressure can literally strip gas out of the galaxy, peeling it away from the disk and trailing it behind in long glowing streams. Astronomers call this ram pressure stripping, and we can see it in so-called jellyfish galaxies. Their stripped gas forms spectacular tails that stretch for tens of thousands of light-years, sprinkled with newborn star clusters. The last burst of star formation as the gas is torn away and compressed. Inside the main galaxy, though, the clock is ticking. Once its internal reservoirs of cold gas are gone, or siphoned into stars, there is nothing left to collapse. Within a few 100 million years, the galaxy's star formation rate can drop by orders of magnitude. From the outside, it transforms from a blue, gas-rich spiral into a smooth, red, quenched system drifting through the cluster like a burned-out ember. But galaxies can also be strangled from the inside out by their own central black holes. At the core of most massive galaxies lies a supermassive black hole, with a mass millions or billions of times that of the Sun. When gas falls toward this monster, it doesn't just drop straight in. It spirals into an accretion disk, heating up to millions of degrees through friction and magnetic turbulence. This process can convert a significant fraction of the infalling mass directly into energy, far more efficient than nuclear fusion in stars, and that energy doesn't stay quiet. It blasts back out as intense radiation, powerful winds, and, in many cases, tightly collimated jets of particles moving at relativistic, near-light speeds. This feedback from an active galactic nucleus is like a cosmic blowtorch aimed at the galaxy's fuel supply. The jets and winds plow into the surrounding gas halo, driving shocks, stirring turbulence, and preventing the gas from cooling down to the temperatures needed to form stars. In galaxy clusters, these jets carve giant cavities in the hot intracluster medium like bubbles blown into plasma, constantly reheating the gas that would otherwise cool and rain back onto the galaxy. Observations and simulations suggest that a single episode of intense black hole activity can keep a massive galaxy quenched for billions of years by maintaining its gas in a permanently hot, puffed-up state that simply refuses to collapse. So, a galaxy's death is rarely a single event. It's the outcome of a long environmental struggle. Ram pressure can tear its gas away, starvation can cut off fresh supplies from the cosmic web, and its own central black hole can heat whatever gas is left beyond the point of usefulness. Yet even in this apparent stillness, the story of a galaxy is not entirely over, because on cosmic timescales, even dead galaxies can be jolted back to life.